Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Hi, all of you. Okay, we hope all stay safe. All right. Can you please? Can you please register at YouTube? Why? Because I need the feedback, and then I need to tick your name as one of the your attendance for today. At the same time, I'm also preparing the games. All right. So this is the QR code. Please view the QR code. Okay. May I know okay, where we stop? Okay, may I know where we stop? Okay, come on. Can I get a feedback from you through the YouTube chat or through the Telegram? All right. Can you please let me know where we stop? All right. I'm also looking at the Telegram now. Okay. So I'm waiting where we stop. Okay. I'm not sure where we stop. All right. This is the question to be answered. I give you a few times. Okay. All right. So your friend said that trapezoidal rules. Okay. Come on. We look at the trapezoidal rule. Oh, okay. We stop at the trapezoidal rule. Okay. Now, we have an example. Okay, related on the trapezoidal rule. Okay. We share screen now. Okay. We share screen. Okay, we go to the YouTube channel. All right. Okay, now I'm sharing you the YouTube. All right. Okay, we are at the trapezoidal rule with the composite. Okay. Now we continue. Okay, let's refocus this. Okay, video. All right. Okay. Right. This is the our subject on the how to find the area below the graph using trapezoidal rule, and then what is the example to apply the trapezoidal rule, and we want to compare with the composite trapezoidal rule. Okay, composite trapezoidal rule, we already give you the formula. Okay, come on, we stop for a while. We go to the notes, okay, that I give it to you. Let's me share screen, okay, to the PDF file. If I can open the PDF file. Mm, okay, let's me go to the PDF file, chapter 6. Okay, share screen again. All right, this is a PDF file. Okay, okay, we learned about the trapezoidal rule. Let's we go to the trapezoidal rule and composite trapezoidal rule. Okay, this is a formula for the composite trapezoidal rule. Okay, H divided by 2, A plus 2 times B plus, okay, there's only A plus B. Okay, what is A? F naught plus Fn. What is B? F1 up to Fn minus 1. All right. So the formula is H divided by 2, A plus 2B. Okay, B is the summation of I from 1 up to n minus 1. A is the F naught up to Fn. So you are going to have 4 columns. Okay, the first column is a F naught up to Fn. The second column is F1 up to F11. All right. So this is the trapezoidal rule. So we learn two methods, trapezoidal rule and composite trapezoidal rule. Composite trapezoidal rule, we divide the area into n number of sub-intervals. Right? The formula again, H divided by 2, A plus 2B. Okay, A is a F0 plus Fn, and then B is a F1 up to Fn minus 1. All right? So, okay, let's we go to the example, how to find the integral between 1 to 4 x divided by x plus 1. All right, using the size of interval is 0.25 and n is a b minus a divided by h is equal to 4 minus 1 divided by 0.25, okay, is equal to 12. Okay, 12 sub interval. All right, so now let's we continue to the let's I share screen again. Okay, let's we go to the previous part is example trapezoidal rule. All right. So now, okay, we are at the here. Okay, we want to solve the integral, okay, between 1 to 4 for the function x divided by x plus 1. All right, we want to find the area below the graph y equal to x divided by z x plus 1. We want to compare which one more accurate, whether basic trapezoidal rule or composite trapezoidal rule. Okay, so in this case, okay, as usual, we do the integral between x plus 1 dx. We know the formula for the basic trapezoidal rule is a h is a b minus a, 4 minus 1 is equal to 3 divided by 2, fa plus fb, because trapezoidal is a trapezium, it's just area the trapezium. All right, 3 over 2, 1 over sec 2 plus 4 over sec 5. All right, so you can get the answer. Okay, the graph here is the area here is including the error, okay, between A and B. So you can go to the trapezoidal rule, use your calculator, you get the answer. All right. So come on, I'm waiting you to get the answer. All right. Can you get the answer? Okay. What is the answer? What is the answer using basic? We are using a basic trapezoidal rule. Okay, basic trapezoidal rule. So can I get the answer? Okay, the basic trapezoidal rule. Please press your calculator. Okay. You can go to page 6, chapter 6, right? You can go to chapter 6. Okay, you will get the answer without, okay, without any formula. The basic trapezoidal rule is come on, we get the answer. Okay, b minus a divided by 2 fa minus plus fb. This is the trapezoidal rule. Can I get the answer? What is the basic trapezoidal rule? Okay, come on, I get from the Pirraven or Low Albani Albara. All right, can I get the answer? What is the answer for the basic trapezoidal rule here? All right, so now, okay, because we know that the answer is not good, okay, there is so many error, okay, between the trapezium and the area below the graph. So we go for the alternative, okay. The alternative method is a composite trapezoidal rule. Is a composite trapezoidal rule by using the size of interval delta x is 0.25, all right, okay, and then the b is a b minus a, 3 minus 1 divided by h is 0.25, okay, So you will get the value of n. N is, you can go here, is a 12. 4 minus 1 divided by 0.25 is 12. All right. So now, since we know the size of interval and then the element or the subinterval, so we can find every particular fi. I start from 0 to 12. In this case, you need to use your calculator. Okay, please use your calculator, mode fix 4, and then press equation, replace fx equal to, okay, fx equal to x divided by zx plus 1. All right, please use your calculator. Okay, I'm waiting you to use your calculator. Okay, because you need to find f naught plus fn. Okay, one part, this one is considered part A, plus another part, okay, 2 times f1 plus f2 until f11, okay, until f11. So you can see, okay, there is 2 parts, means that you need to draw 2 types, okay, column, or four column, xi, I, f0 plus f12, and then f1 plus f2 plus f3 up to f11. All right. So what is f? F is given in the question. Don't worry. All right. So now let's find the solution. Then okay, this is a basic. When we are using a basic trapezoidal rule, the answer is 3.7489. All right. So now we want to apply using composite. Okay, composite trapezoidal rule. So we need to develop 4 column. Okay, what is that? FA, F0 plus F12 is a A. I put as A plus 2 times B. B is a F1 up to F11. All right. So you have 4 columns to find the value of summation Fx with a composite trapezoidal rule. Okay. So now let's continue. Okay, don't forget you have a 4 column to find every F, F0, F1, F2, F3, F4 up to F12. All right. So when you create the table, develop how many column? 4 column. Okay. So you need to create what is a F1, what is X1. X1 is a 1.25. X2 is a plus 0.25 is 1.5. Right? X3 1.75. So you create the composite trapezoidal rule. All right. So now come on. We know that fxi is a xi divided by xi plus 1. So fix in your calculator. Go to page, okay, come on, okay, don't forget, I ask you to go to page, okay, page, come on, we go to page 136, okay, page 136. So you can see here in page 136, okay, you divide the column into 4. I, xi, you generate I, xi from 1.0, 1.25, 1.5, 1.75, and so on. All right, so that's you create until x12 is equal to 4, All right, so the same step, you need to go for fi. Fi is a xi divided by si plus 1. So in this case, okay, you need to separate, okay, F0 and F12 as a part, and then F1, F2, F3 up to F11 another part. We call as a B part, right? So the best of the trapezoidal rule, you can use any n, There is no odd and no even involved, right? There is between F0 and Fn one part, and then F1 up to n minus 1 another part. All right. So the second is you need to create the xi, x1, x2, x3, x4, where the size of interval is similar, is 0.25. All right. So come on. I cut between F1 up to F11. I put a part, okay, another part to make sure that you have to fulfill the formula h divided by 2, a plus 2b. A plus 2b. All right. So come on. Okay. We know all the values for the fi. All right. And then we need to do a summation f1 plus f2 plus f3 until f12. So we put apart because we don't want to mix up with the value of f1 up to f12. So this is a value that you get. Okay. Come on, we focus this. Okay. We want you to write this table like this. You can see how you draw. Okay. F0 up to F12 is an A part. F1 up to 11 is a B part. All right. So you just fit in into the composite trapezoidal rule. You just fit in after getting the summation from where? From calculator. From the calculator, and then do the summation F1 up to F11, and then A part is a F0 up to F12. All right. So press your calculator, please. You can get F0 plus F12 is 2.4960. F1 plus F2 plus F3 plus F11, you will get 14.4435. All right. So this is the 4 column that I mentioned here. All right. This is very important. I don't want you to miss up. Okay, the solution. So please remember the formula H divided by 2, A plus 2B. A is summation of the F0 and Fn. B is a summation between F1 up to n minus 1. All right, so we have 2 parts. Okay, the simplest of trapezoidal rule, okay, they can use any n. You can put H0.1, you can put H0.2, all right, you can put H0.5 and so on. So they are available for any n. N for 12, N for 6, N for 9, N for 11, N for 8 or 7, because there is no rule for the Simpson's rule. So in this case, okay, maybe we ask you to find a formula. Okay, find a formula fx from A to B. A equal to 1 and B equal to 4. Right? So you need to create the formula. This is a common because trapezoidal is a very basic using trapezium. Right? So based on this formula, you can see, okay, you can compare if you have this exact solution. All right, if you have an exact solution, you can see that composite trapezoidal rules much more better than basic trapezoidal rule. This one, if you want to use 6 number of interval. All right, so when you use 6 number interval, so you still implement the formula h divided by 2a plus 2b. What is a? F0 plus Fn. What is b? F1 plus F2 up to Fn minus 1. All right. So this is a common exercise. They ask you to prove the formula using composite trapezoidal rule. Second, all right, reduce the formula by increasing the size of n, okay, the size of interval. Compare with the exact solution, you can see that the composite is much more accurate, okay, is much more accurate. So this is one of the good example to show, to compare between the composite and composite and without composite. All right. So what we want to focus here actually, what I want to focus here, I want to focus that, okay, there is an error between composite and without composite. Okay. All right. So now I want to ask a question. What is the error? Okay. What is the error? Okay. How to reduce the error? The second question is how to reduce the error. Come on. I hope okay, since you are registered your YouTube, please answer the question through the YouTube chat, all right, or talk chat room. All right, so now my question is how we want to reduce the error and what the error actually, okay, that I propose here. What is the error? All right, so you can see here, okay, the error, okay, let's refocus to the, okay, our notes, okay, the error when we compare between trapezoidal rule and composite trapezoidal rule, the error is between the area below the trapezium and the error between the below the graph. So there is a between the trapezium and then the graph. So you can see that using trapezoidal basic, using a 2 point A and B, the error is very big. But when we do the composite, okay, the trapezium for every particular element, for every particular subdomain, for every particular sub partition, okay, you can see the error can be reduced, okay, because the trapezium we develop is very small, and then the graph we partition into a number of subdomain. So trapezoidal rule is composite trapezoidal rule is much more better. They have a small error compared to the trapezoidal rule. What is error? The area between the trapezium and the graph, okay, under the function y equal to fx. All right. You can go to exercise 6.1. You can compare between the composite trapezoidal rule and the basic trapezoidal rule for x between a equal to 0, b equal to 3, fx 1 over x squared plus 1. All right. So what is the size of interval that you are going to propose is depend on you. In this case, you can use 0.5, okay, 0.1, all right, okay, because in our case, we are using 0.3. 0.3 means that you have 10, okay, 10 number of interval. So you can also use odd or even number. Don't worry, because trapezoidal rule, composite trapezoidal rule, they never involve odd or even number of n, right? Odd or even number of n. Okay, so this is our okay, class today, okay, about the how we solve using composite trapezoidal rule, about the composite trapezoidal rule. How many way we can solve? Okay, there are two ways. The first is, okay, you can use composite, and then the other way is you can compare with the basic or basic trapezoidal rule, h divided by 2 fa plus fb. All right, composite trapezoidal rule, h divided by 2 a plus 2b. All right. So now, so we can answer this question. We reduce the error between the graph, okay, area under the graph using composite trapezoidal rule, because the difference between the graph and then the trapezium is very small. All right. What is the error? The error is between the area under the graph and then the trapezium, okay, area. All right. So the difference between graph and trapezium we call as an error. Okay. So we go to 6.1 exercise. Okay. Go to exercise 6.1. Okay. All right. So you can get more detail the powerful of composite trapezoidal rule. All right. Go to your Telegram. Okay. If you go to your Telegram, I already post one questionnaire. What is the questionnaire? You go to the questionnaire, my questionnaire. Be careful when you want to answer the question. Okay, go to the questionnaire. I send you the link. Okay, you can go to the link, right? Okay, be careful. Okay, because the question here is, okay, what is different between center, forward, and backward different formula? All right, so come on, this is you need to refer to chapter 5. And then the second question, okay, what is the difference between trapezoidal rule and Simpson's rule? So this is also the next question that you need to be aware. Okay, do not answer the question. Okay, towards the end, we finish what is a Simpson's rule. All right, to make sure that trapezoidal rule can be corrected, okay, so we apply Simpson's rule. Simpson's rule using Newton forward or Quadrant, okay, Quadrant polynomial function, right? So this is the way. We not say that the graph is the area in the straight line like trapezium, but we can also assume the graph is in the curve. All right, come on. I stop sharing here. Okay, this one you can answer later. I stop sharing. I go to the Simpsons rule. Okay, I go to the Simpsons rule. Right. Mm-hmm. All right. So, what is a Simpsons rule actually? All right. You can go to page. Come on. Okay. Or you can. I stop sharing first. I go to the e-books. Okay. Come on. We go to the e-books. Where is the e-books? Okay. We open the PDF file. All right. In chapter 6. Okay. We go to the chapter 6 Simpsons rule. All right, we share with you now chapter 6. Okay, all right. Okay, this is the Simpsons rule. What is the Simpsons rule? It's come from the quadratic polynomial. Okay, or polynomial quadratic. Y equal to ax plus bx. Okay, a ax squared plus bx plus c is a quadrat, x power 2, the maximum. All right. Okay. The Simpsons rule we can correct using the integral between fx. Fx is a quadrat polynomial. Okay. So we can get h divided by 3, fa plus 4, a plus h plus fb. Meanings that we have two column. We have two column. A to x1, x1 to x2. We have two column. Meanings that whatever area under the graph, you can assume that the graph in the parabolic form. Okay, so the draw graph, the dot is the area that you're going to find. However, there is an error between the area below the graph and then the area from the polynomial quadratic. So how to reduce it? We are apply composite. All right. When we apply composite, so there is a number of n involved. In this case, be careful. Okay, the n, because this is a 2 point, okay, which is x2 is even. So make sure that the n is should be even. For example, n equal to 6, n equal to 8, n equal to 4, n equal to 12. So be careful. So the weaknesses of Simpson, what is the weaknesses? Is based on the size even. N should be even. All right. Okay. So we go to the Simpsons rule. I stop sharing here. It's come from, again, I said that Simpsons rule is come from the polynomial quadrat or parabolic. All right. And then it's based on the two element, two subinterval, two subdomain, two partition. All right. Okay. So now I stop sharing. I share with you the the notes here. Okay, I share with you the notes. Okay, so the Simpsons rule. Why we learn Simpsons rule? The issue here is why we learn Simpsons rule. Why that is important to learn Simpsons rule? Okay, because Simpsons rule. Okay, we continue. Okay, Simpson's rule, we correct from the Newton forward divided different formula. You still remember the Newton forward different formula, F naught plus R, delta F naught plus R minus 1 divided by 2 factorial delta squared F naught. All right, so it's come from this formula. All right, so this is a polynomial quadrat. Okay, power, the degree is a power 2. So what is R? R is the number of x to achieve x naught to achieve x. All right. So R is x minus x naught divided by h. What is h? H is the size of interval. What is s naught? S naught the early data. All right. So now, okay, we want to do the integral between a and b, or s naught up to x2 for the function fx dx. Okay, come on. We need to use even number. Okay, 2, 4, 6, and so on. So for the basic, we use between x0 to x2 for p2x dx. All right. So we want to integrate the Newton forward difference formula respect to x. Okay, come on, we fit in what is a P2. What is a P2? Is a F0 plus R delta F0 plus R minus 1 divided by 2 factorial delta squared F0. We want to differentiate respect to x. Okay, come on, we do that. Okay, and then because we make it as standardized, okay, x0 is equal to 0 and x2 is equal to 2. Make it in standardized or dimensionalize the function between x0 up to xn. All right. So now we differentiate since we have r equal to x minus s0 divided by h. So we do the first derivative r respect to dh, okay, because we want to replace the x, okay. Dx respect to h or r, okay, respect to x, okay, respect to x, okay, make it clear. So we can get, okay, differentiate r respect to x is 1 over h. So meaning that dr or x is equal to h dr. All right. So we replace, okay, we replace to the integral function, okay, every x we replace as a r. Okay, so now we can get h we put outside, f naught, okay, integral respect to r is a r f naught. R power 2 here, okay, you want to integrate r power 2 dr, you will get r power 3 divided by 3. All right, so this is a common integral, basic integral that you learn before from the calculus, all right. So now when we continue this part, okay, we integral, okay, f naught r, okay, h, okay, what you will get, we will look and see. It's very simple. Integral respect to r, okay, you can get f, okay, h you bring outside because h is not included in the integral. You just want to find integral f naught, integral r f naught, integral r minus 1 divided by 2 factorial. You can get r f naught, r power 2 divided by 2 delta naught, and then the other one is a 1 over 2 r power 3 divided by 3 minus r power 2 divided by 2, okay, f naught. Okay, so now you are success to integral the function of Newton forward respect to r. Okay, respect to r. Okay, so now, okay, we want to create the Simpson's rule, yeah, don't forget. So make it more simple between 0 and 2. Every r you replace 2. Okay, every r you replace 0. You can get 2 f naught plus 2 power 2 divided by 2 is equal to 2. F naught, f1 minus f naught, 1 over 2, okay, 2 power 3 divided by 3 minus 2 power 2 divided by 2, right? Okay, and then delta squared f naught you learn from chapter 5 is a f2 minus 2 f1 plus f, this one is a f naught, all right, f1 plus f naught minus 2 f1. Okay, this one you learn from chapter 5, okay, the second order derivative. Okay, the second order derivative, you still remember fi plus 1 minus 2 fi plus fi minus 1. All right. So now make it more simple because we want to create the basic Simpson's rule. You will get, okay, because there is a f naught, you minus f naught, and then there is a f1 and f2. All right. So you can get f naught plus 4 f1 plus f2. So very simple. Okay, the formula for Simpson's rule now, the integral between a and b fx dx will be h divided by 3 f naught plus 4 f plus a plus h plus fb. All right, there are 3 terms. Okay, there are 3 terms. What is h? H is a size of interval b minus a divided by n. What is n? N is a number of interval, number of subdomain. All right. So in this case, you can choose any types of n because okay, not any type, but the even, okay, the even n. All right. So the question here, how to develop the composite Simpson's rule? So this is my question. All right. So now we continue here. Why we need composite Simpson's rule? So this is one of the issue we want to answer. Why we need composite Simpson's rule? All right. Okay, this is a question I want to answer. All right. And then second is what is different? What is the difference between trapezoidal rule and Simpson's rule? So this is my question. All right. What is different between Simpson's rule and composite Simpson's rule? All right. So now there is a question from your friend. May I know when even will be used? Even. All right. So since we are using composite, okay, since you are using Simpson's rule is available for even, okay, not odd, okay, meaning that because we partition the data into two subdomain, so the even number, okay, for example, 2, 4, 8, 6 are available to apply Simpson's rule, all right? But if there is odd, okay, you can use trapezoidal rule. Trapezoidal rule is available for odd and even. The n is a number of interval, number of subdomain, number of partition, right? So this is the answer. Okay. The first question that I want answer here, why we need composite Simpson's rule? Because we want to increase, we want to correct the basic Simpson's rule. All right. We want to increase, we want to optimize the error. Error is what? It's come from the curve graph between the graph of fx and then the curve graph they are created by the Simpson's rule. We want to reduce the error. Same as trapezoidal rule, we want to reduce between trapezium and then the graph, okay, curve from the y equal to fx. Same. Okay. So now the second question, what is different between trapezoidal rule and Simpson? This is, I want to answer your question, Chem Kaizi. Okay. So to answer your question, I said that trapezoidal rule available for any n. All right, very easy to prove. Simpson's rule is available to, all right, two partition. All right, two partition. The basic is come from the quadratic polynomial. It's come from the Newton forward different formula order 2. All right, so this is different. So Simpson's rule is better than trapezoidal because they said that the graph is in the parabolic manner. Trapezoidal rule in the trapezium, manner. All right. So now I want to go to composite Simpson's rule. All right. So now let's go to the composite Simpson's rule. Okay. Okay, what we do now, please, okay, be careful because I'm afraid there is proven the composite Simpson's rule based on the n equal to 6 equal to 8 equal to 10. So you need to prove that. Okay, now I want to write the formula for the composite Simpson's rule. So other question is how to prove the Simpson's rule based on 6 number of interval, for example. Okay, how to prove the composite Simpson's rule based on the 8 number of interval, for example. So in this case, you write, okay, h naught divided times f naught plus fn. You write following the basic Simpson's rule plus 4 f1 plus f2 plus f1 plus f3 plus f5 plus f7, the odds value plus 2 f2 plus f4 plus f6 plus f8 is an even number. So you have another column, 5 column. Okay, f0 plus fn, 1 column. Okay, A, B column is summation Fi, I is odd, and C column is summation Fi, I is even. So you can get H divided by 3, A plus 4, B plus 2C. So this is a N should be even. Yeah, N should be even. So I want to create this formula. Okay, I create this formula. I do it one by one. Okay, so since okay, I want to share with you. If I can go to this PDF file. Okay, come on. If I can go to the PDF file. All right. Okay, PDF file, chapter 6. All right, I stop sharing. I go to the PDF file to make it more clear. All right, so I want you to prove this one. All right, I want you to prove this one. All right, I want to find the three areas of graph fx. Okay, so for every area, you can see I have a three area here. Okay, because every column should be two two parabolic, one parabolic, second parabolic, and third parabolic. This one is a maximum, minimum, okay, and then maximum again. So there is three area, f naught up to s naught up to s2, s2 up to s4, and s4 up to s6. So I put in the area like this, okay, s naught up to s2, s2 up to s4, s4 up to s6. All right, so every area I apply the basic Simpson's rule. H divided by 2 f naught plus 4 f1 plus f3 f2, h divided by 3 f2 plus 4 f3 plus f4, h divided by 3 f4 plus 4 f5 plus f6. So I have three areas. All right, and then okay, I put in a group. Okay, you can see the even all times 4, and then the odd is okay. The odd all times 4, the even times 2. Right, so you have two column. A is a f naught plus f6, B is a summation odds fi, and then C is a even fi. Right, so you can create this formula, and you need to say that this is proven for the composite Simpson's rule. All right, so now let's we stop sharing here. Okay, we want you to go to the our notes. Okay, our notes. Where is notes here? Simpson's rule. All right. We want to create the Simpson's rule. Okay, come on. Okay, every particular part we apply the basic Simpson's rule. Okay, we know that the Simpson's rule formula is H divided by 3, A plus 4B plus 2C. All right, so this is the how we create the Simpson's rule. You can see here one by one. Okay, F naught to F2, F2 to F4, F4 to F6, F6 to F8, and up to Fn. Okay, up to Fn. So all the even value, all the even value of I, okay, of I, S naught to F2, F2 to F4, F4 to F6, F6 to F8, F8, okay, S8 to X10, and so on. So every particular, we do how many partition? 1, 2, 3, 4, 5. 5 partition. You can add F10 to F12 and so on. And then we end up to, okay, Xn minus 2 up to Xn Fn. All right, dx. Okay, so this is what we do. Okay, all the even number. All right, all the x is an even number because why? Simpsons come from the parabolic from the two column. Okay, parabolic from two column, a to a plus h and a plus h to b. All right, so now we apply every particular integral using Simpson's rule. We apply, so we will get h over 3. Come on, please remember, f naught plus 4f1 plus 2. This one is a basic, okay, trapezoidal rule for the first column. The second column, h divided by 3, f2 plus 4, f3 plus f4. All right. Okay, so means that don't forget, apply every particular subdomain using Simpson's rule. And then plus f, h divided by 3, f4 plus 4f3 plus f6. So come on, I hope you can do it like this when you want to compare the formula of the Simpson's rule. All right, composite Simpson's rule. All right, and then next is a f6 plus 4f7 plus f8 plus f10 plus 4f9, all right, f10, f8 plus 4f9 plus f10. All right, and then you can continue up to fn minus 2. Okay, now you look the pattern. Okay, the odd value you times 4. Okay, almost the odd value of I is times 4. Right? The even value, okay, you can plus from the previous, okay, expression and then the forward expression. For example, f4 plus s4, f2 plus f2, all right? f6 plus f6, f8 plus f8, f10 plus f10, all right? So there are two parts, odd and even. Okay, come on, we do the summation, right? Unless you cannot do any summation to f0 and f12, you cannot do. So f2 plus f2 is a even number, f4 plus s4 is an even number, f6 plus f6 even number again, f8 plus f8 even number, right? And f10 plus the previous expression times plus f10. So f12 cannot be summation for any numbers, and f0 also cannot be matched for any numbers, okay, for f0, okay. So the answer is f0 plus fn plus, okay, since there is an odd number, all right, 4 times the summation of f1 plus f3 plus f5 plus f7 plus f9, okay. So there is a summation of the odd number. We call as a b, all right, b. So a plus 4b plus 2c, f8 plus f8, okay, f4 plus s4. So there is a 2h over 3. So you put 2 here inside. 2 times f2 plus f4 plus f6, all right, plus f8 plus fn minus 2, all right. So meanings that you are already correct, okay. Let's say I ask you stop at f10, you stop at f10. But this is the way how to prove that the composite trapezoidal rule for n sub-interval. N is an even. Okay, n should be 8, 6, 10, 12, the even value. All right. So the answer is a h divided by 2 times a plus 4b. B is a summation fi. I is a even number. Even, I is even, yeah. 1, 3, 5, okay, 7. And then plus 2 times summation fi. I is a, this one is odd, sorry, fi is a even. Okay, even is a genap, yeah. Odd is a ganjil. So please remember this formula, h divided by 2, a plus 4b plus 2c. Okay, a plus 4b plus 2c. All right, so now my question. Okay, come on, if I can ask you a question here. All right, okay, thank you very much. Okay, thank you very much for your feedback. Okay, now my question here. Okay, how many columns? My question. How many columns for composite Simpson's rule to be created? How many? How many? Because we need to find the summation fi odd and summation fi even. Am I right? So how many columns that you need to develop compared to the trapezoidal? Trapezoidal, you need to develop 4 columns, I, xi, F0 plus F12, and then F1 plus F2 plus F3 plus F11. However, in the composite, okay, 5 column, very good, okay. Belum ada cakap, very good. Okay, my question is how many column they need to create for the composite Simpson's rule? 5, because XI you generate by your own based on the N and H given in the question, and then F0 plus Fn, and then the odds value, the summation Fi is odd and summation Fi is even. Alright, for odds you need to times 4, for even you need to times 2. So the formula is what? H divided by 3 times A plus 4B plus 2C. C is a summation for Fi, I is even. Alright, so now, my question, how to apply? So that's the next question, how to apply composite Simpson's rule? Okay, this is my question, how to apply composite Simpson's rule? How to compare between the basic Simpson's rule, okay, basic Simpson's rules, remember, H divided by 2, FA plus H plus FB, am I right? So how you want to apply the composite Simpson's rule into the composite Simpson's rule, the basic Simpson's rule apply to the composite Simpson's rule. How to find the comparison, which one is much more better? So this is a question. All right, so now we go to the stop sharing. Okay, stop sharing. We go to the next. Okay, the next is we apply composite Simpson's rule. All right, don't say that I'm too fast. You know why? Because I think okay, never mind. We stop sharing first. Okay, I want to share with you the chapter 6. Okay, I want to share with you chapter 6. All right, so we go to the chapter 6. Okay, we want to apply the composite Simpson's rule. All right, so keep in mind, okay, when you get the question like this, what should you set in your mind? The first in your mind is, I know how to create the formula for composite Simpson's rule based on 12 sub-interval. I can prove it from the basic Simpson's rule. All right. Second, set in your mind, I know how many number of sub-interval based on the formula B minus A divided by H. Third, okay, I know how to create 5 column, okay, to find the summation of the Fi odd and Fi even. I know how to press the calculator by insert, okay, the value of F is a X divided by X squared plus 1. All right, so in this case, okay, please press your calculator. I don't want to go further. You press your calculator. This is I'm worried, okay, because you need to answer in 20 minutes. Can you press your calculator to fix F equal to X divided by third X squared plus 1? All right. Okay, can you press? Okay, so can you press? Okay, can you insert the value? Okay, can you not insert the value actually? Can you find a fx using calculator? Using your calculator. So I'm worried, okay, because if you take time to insert the data using your calculator, so I'm worried this one. All right, so I teach you mode fix 4 for 4 decimal places, find equation, okay, press 4 here, and then you can get fx x squared divided by s squared plus 1. All right, so you calculate what is the value of x, and then f is a 0.7071. No need to do manual. You just press the calculator, x 1.25, fx is 0.7809. You need to do 12 times, 12 times. And then when you insert the data, please put in the 3 column, F0 plus Fn, the odds value and even value. All right. So you can see here, okay, your okay, your the way how you create the table is like this. Okay, very fine. And then you know, okay, which is odd, which is even, and then apply the Simpson's rule. What is the Simpson's rule? Is a H divided by 3, A plus 4B plus C. What is A? F0 plus F12. What is B? The summation Fi is odd. What is C? Summation Fii is even. All right. So now the answer, when you put H 0.25 divided by 3, the F0 plus F12 1.6772, F odd value 5.4247 plus 2 even number, you can get the answer 2.070889. You can compare with the basic composite trapezoidal rule and then the exact solution. You can find that the composite is much more better compared to the Simpson's rule. All right. So now I love if I can go to my channel. Okay. I love if I can go to my channel for the example of composite Simpson's rule. Okay, let's I find through my channel. All right. The same time, you can go to the e-learning. Okay, come on, you can go to the e-learning composite Simpson's rule. Okay, you can find there is notes, video. Okay, go to the e-learning. You can find the material there, and then there is quizzes. I'm going to open the e-learning. Okay, trapezoid rule. All right. Okay. Now, if you go to this, okay, I'm stop here. Okay, I'm share screen. Okay, I want to share screen. Stop sharing. I share screen with you now. Okay, the um, composite Simpson's rule. Okay, the example of the composite Simpson's rule, right? Okay, you can see here, okay, very clear. I want to focus the example of composite Simpson's rule. Okay, you go to page, okay, you go to example 6.2. Okay, you can go to the example 6.2. I give you the formula, H divided by 3, A plus B plus A plus 2AB and plus 2C. Okay, B is a odd summation of the odd Fi and C is a summation of the Fi, I is even. Alright, so now we want to apply this formula, okay, this application, summation 1 to 4, okay, integral 1 to 4 for function x squared plus 1, okay, we already know that we need to find the value of xi, okay, we need to find the value of xi, and then this is the style that we are going to implement, all right, the matrix, okay, and then the fx you can get through the calculator, okay, this one I already showed to you, and then you can refer to the notes, okay. So to find the integral fx dx, okay, using the composite Simpson's rule, the formula is h divided by 3, a plus 4b plus 2c. What is A? A is a summation, F0 and F12. What is a B? B is a summation, Fi, I is odd value. And what is C? C is a summation, Fi, I is a even value. All right. So don't forget you have 5 columns. you need to find another three column, which is very important: A, B, and C. All right. C is a summation I is a even. B is a summation I is odd, and A is a F naught plus Fn. Come on, use your calculator to find the value. No need to do manual. However, to do summation of odd and summation of even, you need to do manual. Okay, how to find Fi, you need to press your calculator. All right. So now you can get the answer. Come on, where is the answer? The answer is by insert the value in the column. Okay, the area between 1 to 4, x divided by x squared plus 1 is 2.7089. All right, 2.7089. All right, so means that you need to develop how many column? How many column? 5 column. All right, so now let's we go to your e-learning. Okay, you go to your e-learning. Okay, go to your e-learning. You can find here. Okay, I send to you the e-learning. Okay, uh, I already post to the e-learning. Go to the e-learning. I stop sharing. Okay, I share with you the e-learning. Come on, where is the e-learning? All right. Okay, this is your e-learning. All right. So when you scroll down, you can find here is my link. Okay, there is a YouTube, and then second, I want you to go to these quizzes. Okay, I come on if I can turn it on. Okay, I turn it on, and then I go to the this week. Okay, refer to this week, and then I show the quizzes. Okay, the quiz here, you click here, you can get the question. Okay, use the composite trapezoidal rule to make a difference when using n equal to 2 and n equal to 4. Okay, how the composite trapezoidal rule look like. All right, and I hope you can also prove the formula for composite Simpson's rule for H equal to 2 and the composite Simpson's rule for H equal to 1. All right. Actually, the basic Simpson's rule is H equal to 4. All right. So please use this one and then send your answer. Okay. Through this. Okay. There is a column here. Okay. You can send your answer. Okay. Come on, send your answer here. I'm waiting your answer at the quizzes. All right. And then if you go to down here, I scroll down here. Okay, I'm also post to your, I post at your Telegram. Okay, this is the more information about the revision in chapter 3, 4, 5, 6. Okay, go to your Telegram. I post. All right, and then you can also go to the here. Okay. Mm, come on, where is your? Okay, I'm already post. Ah yes, I am already post you here. All right, you can please answer. I put at the chat. Okay, at the chat here. All right, please work in the group. Okay, please work in the group to answer this question. Okay, come on. Okay, this is a question. You go to the Padlet. Okay, you go to the Telegram. You can find your task in the group. Okay, so now you can see here. All right, I give you example. Okay, for some test 2 in passive question, you go before we do a revision. Okay, for test 2. And also, I send you the, okay, go up here, right? There is a I print screen here. Okay, I ask you to answer this in quiz, all right? And then please submit before 12 midnight. Okay, please submit 12 midnight. I send to your Telegram. Okay, okay, please submit before 12 midnight. Okay, tonight lah. Alright, tonight. Okay. Alright, so this is the two tasks. Okay, once you know how to answer the question, once you know the formula, you can submit at the e-learning, and then this is under quizzes, and then the other one is under working group. Okay, another one is a working group. All right, so now, okay, any question? So my question here is, do you have any question? All right, about you learn today is a composite Simpson's rule. Is come from the basic Simpson's rule. Okay, you have to develop five column. Five column. Okay, and then the difference with the trapezoidal. Trapezoidal is using trapezium, but Simpson's rule using polynomial quadratic or parabolic form. Okay, to find the graph and the area under the graph. All right. So, any question? Can I have any question? Okay. Before that, you can go for the Padlet. You can go to the e-learning. Okay. Any question? Okay. Yeah, I think attendance. Okay, we can classify. We can clarify using the submission at the e-learning tonight. Okay, to find the value of n for composite Simpson's rule. For the method, now we call as a composite Simpson's rule. Any question? All right. Okay. Now the question from your friend. Test 2 will cover which chapter? Chapter from interpolation, chapter 3. Chapter 4, okay, curve fitting. Chapter 5, numerical differentiation. Chapter 6, okay, numerical integral. Okay, integral. So I think it's covered up to chapter 6. Okay, chapter 6, chapter now. All right. So tomorrow, next time, okay, we are going, okay, for the next class, we are going to learn 3/8 Simpson's rule. All right. And then Gauss quadrature, okay, Gauss quadrature, and then we go to chapter 7. Chapter 7 is about eigenvalue and vector eigen. All right, we are going to learn Gauss-Green theorem and so on. Very simple. The important is how you do the exercise, especially at the Padlet. All right, at the Padlet. Okay. So any question? No question. Okay. So thank you very much. See you in the next class. Bye-bye.